Hello everyone, and today we're talking about Voltmodding. Specifically, we're going to be Voltmodding this GTX 260 right here. This is a PCB from Sparkle, I think. This is just the card that came attached to the Accelero heatsink that I bought. And I'm going to be using this as an example for how to Voltmod the GTX 260s. Now there's a lot of different versions for the GTX 260, and I can't possibly make a Voltmodding guide for every single one of them. Which means if you want to Voltmod your card and you happen to have a different one, which you probably do, you're gonna have to understand how it works so you can do it yourself. And that's the aim for this video. So I'm gonna be using this card as an example so you see how the process, what it looks like. But I will also be going into the theory so that you can do the Voltmod on your card by yourself with just a few basic things. And yeah, so let's get right into that because yeah, there's some theory that we need to take care of. So, welcome to the theory part of the video. Really, the only thing you need to remember is this part, but for those who are interested and want to know a little bit more, let's go into a little bit more detail. So, if we want to change the output voltage of a VRM, we will need to access the feedback pin, often marked as FB. And the feedback pin is connected to a voltage divider, which here is made out of two resistors. In real life, it's usually a bit more than just two resistors, but you know, a series, like several resistors in series and parallel always create a resulting resistance, and effectively that's just two resistors in series, which makes a voltage divider like this. And that voltage divider will always be wired output to feedback to ground. So our PWM controller uses the feedback pin to measure the output voltage of the VRM so that it can make sure that everything's going according to plan. It is spitting out the amount of voltage that it is supposed to, and any kind of unforeseen fluctuations due to power transients are compensated for. And we can make use of that fact. So we can solder a resistor in parallel to R2, the resistor from feedback to ground. Now, soldering a resistor in parallel to R2 is going to lower the resulting resistance from feedback to ground, which will mean that the feedback pin now sees a lower voltage level than before, which to the controller looks just like our output voltage just dropped. Because the controller uses the feedback pin to compensate for any unforeseen fluctuations, it will now increase the output voltage until the feedback pin sees the voltage level that it is expecting again. So effectively, we've just forced our controller to spit out more voltage, all the while it thinks it's spitting out the exact voltage that it is supposed to. And that's basically how the Voltmod works. And if we now, instead of just using a standard resistor in parallel with R2, use a variable resistor, like a Trimpot or a potentiometer, then we can actively change the resistance that's in parallel with R2, and therefore the voltage level that the VRM will spit out. And that's how the Voltmods work. So yeah, so you go find yourself a Trimpot, solder it from feedback to ground, and you need to know how big the Trimpot needs to be though. So you need a multimeter and you need to measure the resistance from feedback to ground. Basically, you're measuring R2. How big is R2? Then you take R2 and multiply it by 20. And then you take the next biggest Trimpot that you can find. So let's say we measure an R2 of 1 kilo ohm. Then you have to use at least a 20 kilo ohm Trimpot. A 25 kilo ohm is also fine, but a 15 kilo ohm would be too low because, well, the lower the resistance is, the higher the output voltage will be. And if you use anything less than 20 times R2, your output voltage might rise too high. And yeah, you don't want your card booting up at 2 volts. There we also have to say, a Trimpot has 3 legs, but we only need 2. Now I've put a little diagram on what the internals of the Trimpot look like. As you can see, leg 1 and 3 always have the same resistance between them, while leg 2 is the one that can be skewed towards either leg 1 or 3. So depending on which leg you're actually connecting, as you can see right here in my diagram, leg 1 is not used. You wanna have the Trimpot so that leg 2 and 3 have the maximum resistance between each other. Basically, you wanna skew leg 2 so that it is basically the same as leg 1 in this example. Because, well, again, if the resistance is too low, then you're gonna get a super high output voltage, which might be so high that it damages the card. But beyond that, that's exactly what we're doing. So here's the list of what exactly we're doing. We're going to find our PWM controller for the VRM that we want to mod. I'm gonna show some examples right away. We read the part number of that PWM controller. Then we use that part number to look up a datasheet or pinout on the internet. In that datasheet or pinout, we now then look for the FB pin. We find the FB pin on our card, measure the resistance from feedback to ground, multiply the result by 20, select the next biggest Trimpot. Of course, don't forget to set the Trimpot to max resistance between the 2 legs that you use, and then solder the Trimpot between feedback and ground. That's basically what we need to do. And for the first parts, that's always going to be a little bit different because there's many different PWM controllers. So here are some examples. So right here, we have my Zotac 192 core card. And this one uses a PCB that's actually rather common. This is what's known as the refresh reference PCB. So this is a PCB that is sort of like a reference PCB because many different manufacturers do use it, but it is not the actual reference PCB that the early NVIDIA cards use. This one was later implemented as sort of a cost optimization of the actual reference PCB. And this PCB uses an ADP 4100, as you can see right here. So that's the part number. You look up the datasheet for the ADP 4100, and it shows you that this pin right here is feedback. And then by either just looking at the traces if your eyesight is good enough, or by using the multimeter to check what is connected to that pin, you can eventually find something like this right here, where I then soldered my cable to. Same thing for the memory voltage controller. That one's a bit more simple because the memory VRM is usually just a single phase on a GTX 260. Sadly, the cable's above the part number and I don't remember what it was, but you look that up, you find a pin out, you locate the feedback pin, and on this thing it was actually like the leg on the controller was actually big enough to solder directly to it. So I did that, didn't have to bother with finding anything on the PCB that, had a connection. And my tablet just did something stupid. And yeah, and so you get a better idea of where they are on the cards. So here's the vCore PWM controller, and the memory PWM controller was over here. Then here we have a 65 nanometer reference PCB. Now this is actually a GTX 280, not a 260, but as far as I know, the 65 nanometer actual reference 260s use the same PCB, they just don't populate some of the components, like the last 2 memory chips right here, which a 280 has, and I think also 2 of the 5 vCore phases remain empty. Now, the 65 nanometer PCB has a vCore controller that's a bit special, so it's a Volterra VT1165MF. That one has a pinout that doesn't actually have an FB pin. There it's called Sense Plus. And it is right there. And there's also a bit of a complication there, because the Sense Plus pin just goes directly into a via into the PCB without anything that you can solder to. And on a controller like this, you don't want to be trying to solder directly to the pin on the controller, because that is way too small. That is not going to happen. Luckily, I found a video on modding GTX 280s on YouTube that said that you can just use that one spot on the back to solder to the Sense Plus pin. And a little bit of multimetering has verified that that's true. That pad on the back is actually connected to the Sense Plus pin, which is basically the FB pin for a Volterra controller. So you can get your controller that way. I don't have a memory controller thing for that PCB. Yeah, you're just gonna have to find that one yourself. It's not that hard. Like, just look up the data sheets for things that you think are the controller, and when the datasheet says something like DC to DC PWM buck converter or something like that, then that's the thing you're looking for. Then here's another example. Here's my Asus card. So here's the memory controller again, and my tablet did a stupid thing again. It loves doing that. Yeah, so here's the memory again. So that one was again big enough to go directly onto the pin. Again, I don't know what exact controller that is, but evidently I was able to look up the part number and find a datasheet. And actually, if it is one of these like 8-pin ICs, usually it is that pin. Like, I think every single time I've had a controller that uses this package, it's been that pin, which should be pin 6, I think. Because it's like 1, 2, 3, 4, 5, 6. And then 7 and 8, and then sometimes there's a pad 9 on the bottom. So, yeah. Then, core controller. This one's a bit special again, because the UP6206AK, which actually doesn't have a full datasheet online, but I was able to find a pinout, which is basically just a small screenshot of the pinout section of the datasheet. Well, this thing also has a feedback pin that goes directly into a via in the PCB, and there's basically nothing to solder to. The way I've found this thing over here was just, I took one of my multimeter probes, connected it to the little pin on the controller, and then just started probing random things around the controller until I found something that beeped. While I was in continuity mode, then I checked, does it actually have 0 ohms resistance? Yes, it does. And I soldered to that. Yeah. And then again, if you want to have context where the controllers are, there's the memory controller. And then right here is the core voltage controller. And then lastly, our card today. So up here is the PWM controller for the memory voltage, because this card, it kind of looks like it just has one big 5-phase core VRM, but actually you can kind of see it by looking at the inductors, because this is says R68 and the others are saying R33. So if the inductors have a different inductance rating, that usually is, well, not usually, that always is the sign that it's a different thing. So yeah, so as it is, the upper phase right here is the memory VRM, and then the lower 4 phases are the core voltage VRM. And the controller for that one is on the back of the card, right here. So, and those controllers are an RT8841. If I remember correctly, that is also the same controller that is on the red Gainward and Palette card. The card currently has the stock cooler on it, and I couldn't disassemble it for this, so I couldn't check, but it is an RT something controller. Anyway, looked up the datasheet. That's the FB pin right there, which traces out here, so you can solder to that thing for your feedback. And then the memory voltage is an RT9259A, which again is one of those really big ones, so that's the feedback pin right there, and that's big enough to solder to directly, and that's what we're gonna do. So yeah, like, the process is not very hard. I think for a beginner, the hardest part will be finding which chip is the PWM controller, and then the actual soldering work, which is why I'm kind of going into it specifically here. But beyond that, it's not really gonna be that hard. And honestly, it might look hard to find the PWM controller, but like looking at this, there's not many things that can be PWM controllers. Like the only other chips in the area of the VRM are these things right here. And if I remember correctly, those are just driver chips for the core VRM. So if you do happen to look up the datasheet for them, that's just gonna say that. So yeah. And then on the front side, there's also nothing really, like there's just the MOSFETs themselves, and then this chip, which is the memory PWM controller. And then on the left side, there's a, here's also like the PEX voltage circuitry, and then somewhere in there, there's also going to be power delivery for the little display chip. That of course also has its own VRMs, but we're only going into memory and core voltage today. So yeah, like it's not really that hard to just kind of guess what the PWM controller is, because it is usually the most complex or like biggest chip that's the closest to the VRM that you're looking at. In some rare cases, it can be different, like some AMD cards use one controller for multiple VRMs, and one of those VRMs is sometimes on the other end of the card. Then it's a bit more complicated. But you're also going to notice that when you look up datasheets and one of the datasheets says it supports dual output, and then there's more VRMs than there's PWM controllers on the PCB, so it kind of just, yeah, it just solves itself. But in essence, this right here is what you need to know for the theory part, and we're gonna put this into practice right now. So here we are again. So now that we know what PWM controllers we have and where their feedback pins are, it's time to measure their resistance. So let's get our multimeter right here. And let's measure the resistance from the feedback to ground on our core PWM controller. So we just take any random ground, like this screw hole right here. And then we go to that little capacitor that we marked, and we see 1.33 kilo ohms. So multiply that by 20, and that makes just over 30k ohms in resistance. So then we have this handy bag of Trimpots right here. I got this bag from Elmor Labs. He sells like exactly this. It's just Trimpots in various sizes that are usually used. I don't think I have a 30k, so I'm probably gonna use a 50k. So this is 100, 500, 5k. Is that that's 200 probably. 1k, 2k. What do we have here? 10k, 50k, those would be okay. Then we have 500k, that's way too much. And lastly, 20k. So 20k would be not enough. That would be pretty low. Like even if you put in max resistance, you're probably still gonna get a pretty much very much higher than stock voltage out of those, whereas if you set these to maximum resistance, the effect they have should be pretty minimal, and you're gonna get close to stock voltage. So we're gonna get 150k for core, and let's check memory. So again, we find a random ground. So this strip on the CAN types always marks the ground side, and here's an unpopulated pad, so let's just take that. And let's go to the feedback pin of the memory controller, and we see 0.58 kilo ohms. So yeah, like slightly above 10 kilo ohms would be what we need. So for this we can use one of the 20 kilo ohm Trimpots. So right here, just gotta make sure to not confuse the two. It wouldn't be the end of the world. It wouldn't be like, for some cards you actually need like a 100 ohm and then a 20k. If you confuse them there, you're gonna have a pretty big problem. If you confuse these, we're just gonna have a higher minimum V-core voltage. But yeah. By the way, if you wanna know how to see the resistance normally, there's this little code on all of the Trimpots. So you see this one says 503 and this one is 203, and like those codes say that one is a 20k, the other is a 50k. So if I'm correct, like the first two just says it's a 20 and then the 3 says that it's 1000. And if it was like a 2002 it would be like 200, and a 2001 it would be 20, and a 2000 would be 2 ohms or something like that. I'm not entirely sure, but you can tell by the code. So 50k goes here, the 20k goes here. And what we need to do now is, well, we need to decide which legs we're going to use. I like to use the two that are on the side of the knob. As you can see, I have them with a thumb knob. Usually they come with a little screw knob, but the ones from Elmor Labs always have a thumb knob, so you don't need a screwdriver to turn them. And I tend to not use the one that's away. In this case, it's pin 3. As you see on it, it says 1, 2, 3. So I'm just bending it up. We're not using pin 3. And now, of course, we need to set both of these to the maximum resistance. So to make that a little easier, we can use some alligator cables, connect those to our multimeter probes. So we have this. And the other one. And this is the 20k. So we set to 20k, and we see that by default we have about 8 kilo ohms, so about half of what the potentiometer is rated for. That's usually the case. At factory you usually get the pin number 2 just like sorta in the middle. So now we turn one way and the resistance goes down, so we want to turn it the other way until we see 20 kilo ohms or close to it. You can sometimes also hear a little clicking sound once you've reached the end. It's still going. And we've gone over to 20k. Yeah. There's also a little click sound. I don't know if the microphone picks it up, but you might be able to hear it. So yeah, so we read pretty much exactly 20 kilo ohms. So this one is now good to be used. And now we are getting the other one and also set that to maximum, so that we don't blow our card up when we boot it up. So this one goes up like that. And we keep going until we see 50 or just hear clicking. That looks like it's not going higher. I don't hear any clicking. But this is close enough to 50 kilo ohms to be okay. So we're gonna consider this one prepared as well. So, and now comes the soldering part. So we're gonna connect these to the feedback pins and then some ground that we find. I do have a suspicion that maybe this little pad right here is actually ground. Let me check that. So what resistance? By the way, for NVIDIA cards, this middle tab, or these tabs on the outside of the SLI fingers, are always ground. So if you ever, like, there's a few places that are always ground. For NVIDIA, this one is just really convenient. So let's check what resistance we have on this pad. Yep, that looks like ground. That is ground. So we can use that pad as ground. Or we could also just use these like the if the clip is on this side of the connector, these pins are always ground. But these are pretty thick, that's a lot of metal, so my tiny soldering iron will not have the power needed to actually melt something to this. But that little pad might be fine, or you just use a random capacitor somewhere, whatever you can find that's convenient to solder to. Like, the ground is everywhere on the card. I'm gonna try using that little pad, and if that doesn't work, I'm gonna search something else, probably like one of the capacitors around here. So yeah, I think I'm gonna put the Trimpots up next to the power connector here. Kind of hot glue them there. Or is there a better way? Maybe hot gluing like one here would actually also be pretty good, because the power connector cables are gonna be here. Yeah, I could do that. Hot glue them on like this. On my test bench I'll have enough space to access them there. So yeah, that's what I'm gonna do. So I'm gonna hot glue these onto the PCB first so that they are just set and are not gonna like float around, so we have to hold them down. So I'm gonna get my hot glue gun and fix these to the PCB. One thing that I'm also going to do while my hot glue gun heats up is I'm gonna mark these which potentiometer is which. So this is the 503. So this one is for core, so I'm gonna mark it with a C on it. And then the other one is the 203. So I'm marking this with an M, so that we always know which potentiometer is which. And now we just have to wait for my hot glue gun to get up to temperature to fix this to the PCB. So my hot glue gun should now be up to temperature, so let's put this on. Let's attach our potentiometers. There we go, that was pretty quick. Let's put a little extra so that they don't fall off randomly in an inconvenient spot. Oh, hot glue always makes a little bit of a mess, but it is quite useful. So, now we have our two potentiometers on the card, and now we can begin attaching the wires. So, I like to do a little bit of intelligent cable routing, so that when you accidentally pull on a wire, you don't necessarily rip off the component that you soldered it to, because that can be a thing. I like to run wires through screw holes like these, because we're not going to be using these anyway. This card didn't even come with anything that used these screw holes, so I can just use them to route cables through them. So, one wire will just be going to ground. That one's not going to be really that big of an issue, but the one going to the little capacitor behind the next to the core PWM controller is rather delicate. So I'm gonna be using the cable right here. Let's strip the end of it. That one's going to be soldering onto the little capacitor right here. And I'm just gonna solder on one end and then route it as we go. So, to have a little bit easier time to add soldering, I'm gonna be using some flux. Put that on. I don't have hot air today. Usually I'd put the card on hot air. But most people will not have that, and you don't really need hot air for this. It makes it a bit easier, but well, let's just show that I can also do it this way. So, gotta be a bit careful with the smoke from the soldering iron. It tripped my fire alarm the other day. So, also it would be helpful to pre-tin the cable a little bit. So let's put some flux on that as well. And just do that a little bit so it sticks easier. And then solder it on. Okay, it is on, and I'm just gonna cut off a good amount of cable so that we have enough. And I'm gonna do my cable routing, so I'm gonna put it through this screw hole here. And while we're at it, I'm going to hot glue it down so that we don't have any accidental cable pull incidents. So let's put a little bit of hot glue here. Let's make a little bit more of a mess, but now our cable will no longer put any force on that little capacitor there when it's pulled on. And let's route the cable a little bit more. Let's put it back through this. Like that. And then can route it here. And then we still have plenty of length to go to our let's put it between these capacitors right here. And then we can solder to one leg of our core potentiometer. So let's cut it like sort of here. Strip the end. Some flux on again. By the way, if you have second thoughts about anything like the legs of the potentiometer touching the outside casing of the capacitors, that's fine. Those don't carry any voltage or anything. If anything, the casing is grounded, but usually doesn't conduct at all. Like, I've had cables and stuff touch the capacitor casing plenty of times and I never had any issues with it. Let's pre-tin the legs here a little bit. Stuff always sticks easier when you pre-tin it. And let's connect this. Well, it could be prettier, but it's connected. So, that's 1 out of 4 done. And the routing's not even too bad. I've seen worse than this. So, we have our connection here. And it routes all the way over to here. And now we connect the other end of the potentiometer to ground. So I was gonna use this pad. Let's just test if my soldering iron is strong enough to put a little bit of tin on that pad. If not, we're gonna have to look for something different. Looks like I might just about have enough. Yeah, it's not super good. I got a little bit of tin stuck to it, but it is not amazing. Doesn't flow very well. But I guess it should be good enough. So, we can just reuse that bit that we cut off. This is probably more than we need. Strip one side. Strip the other. Some flux on both ends. And pre-tin it. All right, let's see if we can get this to stick. Well, it's definitely attached. And now we can do some more clever routing to the other side. Actually, how do we do this? Like that, maybe? Also try bending the leg out a little bit so that we have easier access to it. Let's just connect it and then see how we can route it after. Well, that's on. It just about doesn't fit that. This is gonna be good enough for now. So, our core Voltmod is done. So we have the potentiometer connected to our feedback pin and then to ground. So right now this is not gonna do much, but once the card runs and we turn this, our output voltage should go up incrementally. So, same idea for the memory. Put some flux on here, also on that, and then we can probably just use the exact same ground from before. We are gonna need a new piece of cabling though. This one already has the insulation stripped off it a little bit. This is a bit tricky. That pin doesn't want to fully heat up. I don't want to bridge anything in that area. Yeah, it doesn't really want to hold on to it. There we go. It is connected. By the way, don't do that when you're soldering to a small SMD component. Only doing this because it's directly on the leg. So, we have it connected. And time for some more clever cable routing. How about we route it through here? And through that capacitor, and then we're basically right there. Right. This one should be easier to connect. There's no capacitor in front of it. That's a little bit too long. Well, maybe we can just put it out here a little bit. Oh yeah. And now we need another connection to ground. Shouldn't be too long. We can just bend this again. And sort of like put it along here. Okay. Let's see if I can get in there. Yep, that's on. And now for our ground connection. it's connected. The contact in that area is not particularly great because I'm not really putting enough heat into the board. I'm gonna just try putting another big blob of solder onto it. Hopefully get a slightly better bond. Oh yeah. So, can we route this around one of the capacitor like that? Looks like it's gonna be a bit hard to do that. Maybe around the inductor like that. Yep. Seems about right. And that should be it. So, again, we have our connection to the feedback pin and then our connection to ground. So everything should be working. So let's put a heatsink on this and test it. I did actually find a way to use one of these retention brackets by just cutting the ends off of them. So it just about kinda fits, but not really, but it's still a bit better than not having it. And forgot to put washers below it. Alright, card's assembled. So it's time to test it out. So the cards are running the benchmark, as you can see right there. And I've set the multimeter up to show our V-core voltage. So if I now turn the knob, one way or another, at some point we're gonna see the voltage increase. I may be turning it into the wrong direction though. Yep, there we go. So I was turning it into the wrong direction for a bit. But as you see, as I turn it, our voltage increases. Very slightly. As you keep turning, the increase is going to become sharper and sharper. That's just how it works. But let's keep going to 1.2 volts. Since that's way outside what you can set in software on any of these cards. Except for these 65nm reference ones, but... there we go, 1.2 volts. And if we look in GPU-Z, the card still reports 1.12 volts. So, Voltmod works for Qual. And if we now take the inductor for memory, you can see that the card is at 1.96 volts stock for the memory. Now for GDDR3 that's completely fine if you're freaking out for that voltage level. A lot of cards actually use 2.05 volts for their stock voltage. This only being at 1.96 probably explains why the memory clocks weren't very stellar on this. So let's give it a little help and increase that as well. So we already see that it's slowly coming up. And let's go all the way to 2.05 volts on it. Actually gonna have to change over to the next volt regime because 2 volts is just gonna show up as this. So go here. Oh, that's 2 volts. Now I want 2.05. And here we are, 2.05 volts. So, there we have it. Voltmods work for both core and memory. And most importantly, our card is still alive. Yeah, good temperatures. The temperatures are of course going to be a bit higher since we are now at way more voltage. But yeah, so now you know how to Voltmod a GTX 260 or any graphics card really. This works on pretty much every single VRM ever, with some very rare edge cases. So this is how you do it with Trimpots. I, of course, you've kind of already seen it, have my own way of Voltmodding, so this is how I do it these days. As you can see, there's no Trimpots on here. Instead, I have everything going to this little terminal here, which then has these plugs on it. Because I use this, an Elmor EVC. This is actually the old one. Elmor did send me a newer one. That's that one over there. And the EVC can also simulate or replace a Trimpot with this long header right here that says ground V1, V2, V3, and then SRC 1, 2, 3 on the other side. This, over these pins, the EVC can add or siphon away a small amount of current from the feedback pin, which is effectively the same thing that we're doing here with our Trimpots. Now here we're changing resistances, which leads to a difference in voltage levels. The EVC uses the onboard DAC to inject or subtract tiny amounts of current, which effectively also does the same. It affects the voltage levels at the feedback pin a bit. And yeah, so this is how I do it, but of course you need an EVC for it, and it's a little bit more complicated, and beginners are probably gonna do this with Trimpots, which as you can see works just fine. But don't be confused if you see things like this on my cards, because I prefer the EVC, and you also get the voltage monitoring graphs that you can see in my streams and some of my videos. That's what these two wires do, by the way. They grab the output voltage and then also put it in here, whereas this wire and that wire go to the feedback pin, just as you've seen in the theory part of the video. But that shall be it for now, so thank you for watching. I hope you learned something, and until next time, goodbye.